So this video is to go over the practice problems for Unit 4, Lesson 5, and that section is about saying it with decimals. So here we are. At the beginning of the month, there were 80 ounces of peanut butter in the pantry. Yummy, that's a lot of peanut butter. Since then, the family ate 0.3 or 3/10 of the peanut butter. How many ounces of peanut butter are in the pantry now? Okay, so let's see. Beginning of the month, there were 80 ounces. The family ate 3/10 of the peanut butter. How many ounces are in the pantry now? So that's the key. So we need to do one of two things. We need to either decide to figure out what the opposite of 0.3 is when we compare it to one whole, or we find 3/10 of the 80 ounces and then use that to subtract from the 80 ounces. So we have a choice here which way we want to do it. So I would say, especially based on how the rest of the chapter's gone, that we should use that 3/10 and figure out the opposite. Now obviously it's not really the opposite, but I like to think of it as the complement of it. So we know that 0.3 is what was eaten. So therefore what's left is 1 minus 0.3 or 3/10. And you should know that that leaves us with 0.7 or 7/10 of the peanut butter still left. And then all we do here is multiply 0.7 times 80. And I did neglect to put the choices here, but you should have the choices in front of you in your book. And the only answer that matches ours is choice A. Choice A actually matches this exactly. The other two, if we look at B, B is finding the 3/10 of 80, but we're not looking for how much they ate. We're looking for how much is left. The next one is silly because they're simply subtracting 3/10, which makes no sense at all. And D is as if there's more than the original, which would be really cool if we could, put things in the cupboard and have them come out with more food in them, but I don't think that's going to happen. So the only one is choice A, which is this 0.7 or 7/10 times 80. Okay, next, here we are on a hot day. A football team drank an entire 50-gallon cooler of water and then half as much again. How much water did they drink? Okay, so if we look at the 50-gallon tank, or the 50-gallon cooler as the beginning, so that's our one whole, the entire thing. And then we know that they then drank half as much again. So half of 1 is 0.5 or 5/10. So we add those two together, 1 plus 0.5, or if you kind of in your head think about that like money, if it helps you, $1 plus 50 cents is going to be 1.5. So I've got 1.5 of 50. 1.5 of 50 means that I'm going to multiply those two numbers together. 1.5 times 50. And if you go ahead and do that in your calculator, you should know that it's 75 gallons that they drank. Now, this is a pretty easy one. You can probably figure it out on your own, just knowing that the whole thing is 50, and then half of that again would be 25, and it gets us to 75, which is fine, but really you need to know how to do this. So as I've said numerous times before, a lot of times our examples are with easier numbers so that we know what to do when we get to those harder numbers. So make sure that you get this written down somewhere in your workbook if that's not how you showed your work to begin with. The next problem, Jada has 12 library books checked out. Han has 1/3 less than that. How many books does Han have checked out? 1/3 less. So if we start out in the same way, we know that Jada has 12. And we consider that one whole. That's the whole thing. 1. And Han has 1/3 less. So I would subtract 1/3 from this. So not 1/3 from the 12, but 1/3 from the 1 whole. So just to, be very clear, 1 whole is 3/3 minus 1/3 is 2/3. Now, hopefully you just knew that, but again, it's important that I show all of the work here to make sure you truly understand it. So now I know that the original, or 1 whole, is 12, and I need to know what 2/3 of that is. So what I'm going to do is multiply my 12 times 2/3. So of course you should know to use your math Macarena. Put that 12 over 1. First we will divide. Now we multiply. Keep the top with the top. So 12 times 2 is 24. And bottom with the bottom. So 1 times 3 is 3. 24/3. We know we need to reduce that. Lastly, we reduce. And we know that 24 divided by 3, we should know our times tables, is 8. So that means that 8 books is what Han has. Han has 8 books. Now again, these numbers, you might have been able to figure this out, just logic it out, but you really need to know the proper procedure so that when you're, given numbers that are a little more difficult, you know what to do. Okay, so X represents a positive number, and we're selecting all the expressions, these given expressions, whose value is greater than X. Greater than X. So we know if it's greater than X, means larger than 1 whole. Okay, so if we look at each one of these, which ones are going to be larger than 1 whole? So let's look at A. It says A, there's your 1 whole, minus 1/4. Well, you're multiplying X times something that's going to end up a fraction. That's definitely not going to be larger than 1. So we can eliminate A. And, looks like I made an error. I'm going to apologize for that. Maybe I can use this. I knew just as I looked at it that it wasn't right, so that should be a plus. Let's see if I can make that look better. Plus. Oh, there we go. So it should be a plus. I apologize for my typo. So, again, we're looking at larger than 1 whole. So this is 1 plus that 1/4. Not taking it away like we did in the first one. So since we're adding to it, it's going to be larger than that 1 whole. So B is a choice that we'll keep. Now C, 7/8. Is 7/8 larger or smaller than 1 whole? You should know that it's smaller. So because it's smaller, being multiplied by our X, it's going to be less than, not greater than. So we eliminate that. And then D says 9/8 multiplied times X. 9/8. Remember, 8 is little, holding up the big 9. That means it's larger than 1. So because it's larger than 1, we know that this is also going to fit our description of being greater than X. Ooh, did you see that? That was fun. So greater than X. And there we go. Our answers are B and D. Next. So a person's resting heart rate is typically, on average, between 60 and 100 beats per minute. Noah looks at his watch and he counts 8 heartbeats in 10 seconds. So is his heart rate typical? And explain how we know. Well, I guess the first thing we need to do is, he said 8 heartbeats in 10 seconds. Well, I know that a minute has 60 seconds. And Noah only counted for 10 seconds. So I'm going to divide 60 divided by 10, and that gives me 6. So that means whatever Noah counted in the 10 seconds, I need to multiply times 6. So in 10 seconds, Noah counted 8 heartbeats. So I'm going to take that 6 and the 8 and multiply those together. 6 times 8 equals 48. So that's 48 beats per minute. And if I compare that to the typical between 60 and 100, it is not a typical heart rate. So therefore my answer is no. That's an arrow. No. Noah's heart rate is lower than typical. Okay, next. Now I'm going to write an equation for H, the number of times Noah's heart beats at this rate in minutes. So when they say at this rate, they are referencing what we found here, 40 beats per minute. And they've given us the variables to use. So we're just going to make that clear. We're going to say let H equal, that's funny looking, let H equal the number of heartbeats and then we're going to say let M equal the number of minutes. Now I know some of you get confused here because you try and like say what's equal to what, and that's not what we're doing here. We're thinking about this in the form of an equation. So if I know that Noah's heart beats 48 beats in 1 minute, how would I figure it out for more minutes? What am I going to multiply it by? So if it's 2 minutes, I'm going to multiply 48 times t, which is the number of minutes. If it's 10 minutes, I multiply 48 times 10, which again is the number of minutes. So I want to like think those through, some of those examples in my head. So since every time I multiplied 48 times the number of minutes, I know that therefore I'm going to have 48m, or 48 times m, equal to h, the total number of heartbeats. So there is our equation.